For more complicated exponential functions or equations you're trying to solve, you need to get the exponential isolated on one side of the equation before you apply the definition and write as a log equation. So if I've got a problem like number 5, before I can change the log equation, I need to get that e to the 2x by itself. So what I would do here is I would first subtract 4 from both sides. That would give us 3e to 2x equals 7. And then I would divide both sides by 3. And then I'm going to change this into log form. Now the good news, my base is e, so I'm not going to have to use a change of base formula because I already got e in the problem. And I can take the ln of e directly. So we're going to change this into our log equation. So 2 to the x equals log base e, which is ln of 7/3. Now, if the book asks you for the exact value, what you would need to do is divide both sides by 2. And I'll bring it up here. X equals ln of 7/3 over 2. That's the exact answer. Now, most of the time in the real world, we're not interested in the exact answer. We need to get an approximation. So let's do that here. And you can actually put this thing directly in a calculator. You can go back here, calculate the natural log of 7/3, and then divide the answer by 2. I kind of like doing it that second way. So I'm going to do the natural log of 7/3 first. And then I'm going to divide the answer by 2. And if we round off, that's approximately 0.4236. So that would be our approximation. All right, let's see if we can do problem number 7. So here I'd want to subtract 7 from both sides. That'll give a negative 4 to the 0.03x plus 1 equals a negative 5. Now you might think we have an isolate, but we don't quite have an isolate yet. And I need to get rid of that negative sign. So I'm going to divide both sides by negative 1. That'll give us 4 to 0.03x plus 1 equals 5. Here I am going to have to use change of base. So that would be equal to log base 4 of 5. And I'm going to calculate that. I'm going to use common log again. Common log of 5 over common log of 4. All right, slide this over so we can get the calculator into the game. So we'll do log of 5 over log, whoops, let me try that again. Log of 5 and then log of 4. So that gives us 0.03x plus 1 equals that crazy number. I'm just going to put dot, 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 dot. We would need to subtract 1 from both sides. So that gives us 0.03x equals 0.16 dot, 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 dot. And then divide by 0.3. Now I do that, I'm just trying to avoid any kind of rounding until we're done at the end of the problem. And I think we've been rounding to 4 decimal places, so let's round that to 6.5. So that would be our approximation. Now, I want to take a few minutes to kind of run through how you would do the check. So if I wanted to check this answer, and if I want to be a little bit more accurate, I would just enter this left side in my equation, replacing the x by the answer I have here. So I would do 7 subtract 4 caret key 0.03 times. I'll go ahead and grab that answer. So notice I hit my up arrow to highlight it, hit enter. It puts me in there. And I want to stay up there because that plus 1 is still up in that exponent. Hit my right arrow, hit enter. And something went wrong. So that tells us we did something wrong. So we need to go through and we need to double check our answer. So, because I should have gotten something close to 2, so let's first make sure we entered it incorrectly. And it looks like that part is. So let's check our math. So we subtracted 7 from both sides. That gives us -5. We divide both sides by negative. We wrote it in a log form. Let's check if we did the log correctly. In 1.16, we subtracted 1 divided by 0.3. So we'll just kind of keep running through this. So we have to keep running through this because we made an error somewhere. So let me clear my screen. So let's double check this. Fraction key log 5 over log 4. Okay, that checks. Subtract 1 from both sides. That checks. Divide by 0.03. There's where I made a mistake. I got the decimal in the wrong spot. We divided by 0.3 instead of 0.3. So that's why you always want to check these answers. So now we can fix this up. So this would be 5.3655. So that'd be 5.3655. Now let's check that answer. So I'm going to do, let me clear my screen. 7 subtract 4 caret key 0.03 parentheses. I'll go grab that answer. Hit my up arrow, hit enter. Close the parentheses, plus 1. Now we get 2. So that's why it's a good idea to check these answers. So similarly, if I wanted to check this one, and maybe I'm doing this on a quiz or a test and I've already erased it, and so I don't have the full answer anymore, that's fine. We can still check to see if this answer is close. So I would take, in this case, I would take 4 plus 3 second ln 2 parentheses, and I'll put in that approximation 0.4236. Oops. Help if I entered it incorrectly, wouldn't it? And I should get something close to 11, in which case I do. So even though it's really not required to check these, I always recommend, particularly on these big long ones, if you miss, divide by like 0.3 instead of 0.3, you're going to get the wrong answer. You think you're done, when in reality, you have the wrong answer. So always take the time to double check your answers by plugging it in. It's a good habit to be in. So whenever we're working with exponential equations, we have 2 techniques. If we can write them so they have the same base, we go ahead and do that, set the exponents equal to each other and solve. If, however, we cannot write them the same base, then we use our definition of log, rewrite as a log equation. Might then have to use the change of base, and then we go and calculate the answers. So we've done the first two tools, tool number 1 and tool number 2, working with exponential equations and being able to solve them.